come to this point, the derivation of swing equation. So let's take the theta be the angular position of the rotor field from the reference axis, and this is the stator magnetic field which is rotating at a speed of omega s, and this is the rotor magnetic field or rotor, this is rotating at omega speed. Now from this one, if I want to write the equation for theta, what will be theta? Theta will be delta plus this angle. So this angle, how to take this angle? This field is rotating at synchronous speed, so we can write omega s into t, omega s into t plus delta will be our theta. So see the equation, angular position of the rotor is given by theta equals to this. Now we'll find the angular acceleration. So angular acceleration will be here d squared theta dt square. Now take the first derivative of this equation. If I take the first derivative, d theta dt is equals to omega s into d delta dt. So this is our equation number 2. Here every notations are given, already I have mentioned. Similarly, we want to get angular acceleration, so we have to take the double derivative of this equation. So again take the derivative of this equation. This is constant, so if we take the derivative, this term will be 0, here square term will be there. So see the equation, this is angular acceleration of the rotor, so that is denoted by alpha. So as this is angular acceleration, that's why unit is radian per second, because this is changing, the angle is changing with respect to time. Now this is the model of the generator actually. So here why we have taken this one, because we'll see in case of generator alternator, we have to give prime mover input, and then we will get the electrical output, means mechanical input and the electrical output. If we see the diagram, what we can see here, PS is the mechanical input and P is the electrical output. Now due to this mechanical power input, we'll get some mechanical torque developed on the shaft, and uh, for the generating action, we'll get torque developed in the uh, generator also. Now this is that torque will be the electrical torque. Now this difference between this mechanical torque and the electrical torque will give you the equation for accelerating torque. Now see, TA equals to mechanical torque minus electrical torque. If TS is greater than T, what will happen? This term will be positive, means we'll get some accelerating torque which is positive. So due to that torque, the machine will accelerate. When that is opposite, like electrical torque is more than this mechanical torque, that time this will be negative, means we will get deaccelerating torque, and due to that machine speed will reduce, or machine will deaccelerate. So these are the notations here given. This is accelerating torque, this is shaft torque, this is in terms of mechanical, and this is electromagnetic torque. Okay. Now there is angular momentum. Now what is angular momentum? Angular momentum is the product of actually moment of inertia into speed. So that is m, angular momentum. Now you see here, let's just show the equation, then only you can understand. This TA, if we multiply this one, both side of this equation with omega, then we'll get power here, we'll get another power here, we'll get another power here. Now this will be accelerating power, and mechanical power, electrical power. So that equation is written there. this one, PA equals to PS minus PE if we multiply. So this is the accelerating power. Now, as I said, if mechanical power is more than electrical output power, then machine will accelerate. If mechanical power is less than electrical power, machine will decelerate. Acceleration will increase the speed of the machine. Machine will run at above the synchronous speed. Now, but again there is another thing. Moment of inertia into angular acceleration will give you torque. So that torque, and our moment of inertia was J, and angular acceleration is alpha. This is d square delta dt square, and this is equals to, already we know this one. So J into this is equals to Tn. Now you do one thing, you multiply this one with omega. So what we will get? Omega into J into this, or maybe this, is equals to omega into T. So power is omega into torque, and this side J into omega. J omega is the moment of angular momentum. So this term can be written as angular momentum M, and this is accelerating power. So accelerating power is mechanical minus electrical. So this is the equation which is your swing equation. Now this will give you the relation between angular accelerating angular acceleration and the accelerating power. So the equation which gives the relation between angular acceleration and accelerating power PA is the swing equation. Actually, this is used to find the variation of delta with respect to time. So, and this equation is used to study the dynamics of the synchronous machine. Now, what is dynamics of the synchronous machine? Like if there is any changes in the system load, or maybe any fault takes place, the machine will accelerate and decelerate based on the situation. So that time swing of the angle, rotor angle, will be there, and that swing of the machine is the dynamics of the synchronous machine, and that dynamics will actually behavior of the synchronous machine will affect the performance of the power system. So for this we need to stabilize the swing, or we need to stabilize the dynamics, because otherwise if you do not damp the oscillation, and the system will oscillate and the whole system will get disturbed. So swing equation is the equation which will give you the variation of rotor angle with respect to the time. So that's how the swing equation is derived, and at the end swing curve is drawn. I already have explained this one. As I said, here for stable system there will be no imbalance between mechanical and electrical power, so we will not get any acceleration deceleration. Or from the curve we can say, when this equals to 0, there is no change in delta with respect to time, that is stable system. For unstable system, the d delta dt, the change in delta with respect to time will be greater than 0. With respect to time it will change and change. So that will be the unstable system. So that's all we have discussed there in the class. So this I am doing for you, or go through it.